Here's a past paper problem involving lifts. It's from the WJC's Mechanics 1 2012 paper. A lift of mass 2,500 kilograms is ascending with an acceleration of 1.8 meters per second squared. In part A, we need to find the tension in the lift cable, and in part B, there's a mass that we're not given. We're told the reaction force, and we need to find out what that missing M value is. Feel free to pause the video now, and when you're ready to see the answer, unpause and have a look at the solution. In most problems in mechanics, it's usually a good idea to draw a diagram. So we're going to label the direction of motion as upwards, with the acceleration 1.8 meters per second squared. We've got the tension in the lift cable acting upwards, and then we've got the weight of the lift acting downwards. We can work the weight of the lift out by multiplying 2,500 by 9.8. Going to need to go into the calculator. It's going to give us a weight of 24,500 newtons. When I consider F equals ma, I'm going to put the tension as positive since it's traveling in the direction of acceleration. I'm going to put the weight as negative. The tension is currently unknown. The weight can be substituted in. The mass is 2,500 and the acceleration is 1.8. If I rearrange this statement, I can add the result of what's on the right hand side to 24,500 and I'll be able to get my tension value. Again, this is going to need to go in on the calculator. So we're going to multiply 2,500 by 1.8 and we're going to add on 24,500 to give us a tension of 29,000 newtons. Fantastic. Now for part B, we've zoomed in, and that's because we're given the mass of the person and the reaction force. Well, I say that we haven't been given the mass of the person, but that's something that we're going to need to consider. The acceleration value is still the same. We can still use this 1.8 for A. The forces that we've got acting this time, the weight of the person acting downwards, which we don't know, but we can express as the mass times 9.8. I'm going to write that as 9.8 m. The other thing that we know is the reaction force is acting upwards. The reaction force we are told is 696 newtons. If I consider F equals ma, once again I'll put R as positive since it's traveling in the direction of motion. I'll subtract the weight. What I'll do is I'll substitute in what I can. So I can replace R with 696. I can replace the weight with 9.8 m. I can replace little m with the capital M for the mass of my person. And I can replace A with 1.8. Now this has been reduced to a problem where there's one unknown, M. Might need to do a little bit of tidying up and rearranging first though. So I'll take this over to the right hand side, keep the 696 over on the left. And we've got 1.8 m plus 9.8 m. I believe this will add up to 11.6 m. And to get the mass on its own, I'm going to need to divide 696 by 11.6, and that's going to go on the calculator again. So let's see, 696 divided by 11.6, that gives us a mass of 60, which sounds quite sensible, doesn't it? You know, definitely in the range of reasonable weights for people. There we go, fantastic. That is the problem done.